Okay, welcome back. And what I want to continue to look at is Sittingill's 2357, which became the 5357. Now, again, be aware of changes within the Sittingill's references. Okay, now, although the reference number might change, the data and the technology and the knowledge is still the same. It is still required. Okay. And what you may find is that more information might be added to this unit as time goes by, making it more compelling that you understand and you are assured of you are working within the parameters of the IEE regulations, okay, as they are at that relevant point in time. Okay. Now today we're going to look at session 3, symptoms of electrical faults. Okay. Understand how to complete the preparatory work prior to fault diagnosis and correction work. It's okay, I just got my tongue caught in my teeth then for a moment. Okay, right. Now again, session 3, symptoms of electrical faults. Okay. And here's our outcomes. Okay. Make sure we can get the information in fully. Okay. Thank you. Okay. Specify safe working procedures, etc., etc. Interpret and apply the logical stages of fault diagnosis, etc., etc. Identify and describe common symptoms of electrical faults. State the causes of common faults. Specify the types of faults and their likely locations. State the special precautions that should be taken when fault finding. Okay. Okay, let me make sure to come back. This is fully in view. Sorry about that, just making sure that it is ample and it can be seen in view. Okay. And those of you who need a close-up, here we are. Again, as we said previously, objectives, aimed on objectives. Okay. Now, electrical faults. Okay. Make sure we look at this full. No two situations are ever the same. Okay, so don't assume that because you find a fault on one situation that it's going to be the same on another. It's not. It's always changing. And make sure you are compliant with the regulation 314.1 states. Now again, make sure that this regulation is concurrent with what you're dealing with in regards to the current regulations of the IEE regs. Be sure that this reference number or regulation has not changed in time or in period of times. Okay. Okay, and here I don't need to read this to you. You can read this for yourselves, all right? You're level 3 now. If you're not, then you need to go back and look at some of your revisionary work and look at some of the units I've done previously in regards to my videos. That's a matter for you to deal with, okay? Okay. Most electrical faults would become apparent by loss of supply, low voltage, operation of overload, component equipment malfunction, etc. Arcing. Now, arcing is one of the most dangerous because it causes the cables to melt and will cause the insulation to melt also. So you need to be aware of that. Okay. Now again here, I don't need to read this to you. You read this for yourselves, okay? I just need to make sure that it's fully on screen, okay? That it can be seen by us all, okay? Okay. Okay, good. Now again, you don't need me to be reading this to you. This can tell you what it's about, okay? And let's just go in and have a look at what we're talking about in regards to operational overload and fault current devices, okay? This is what happens when your circuit does not work correctly. And not only that, and the fire may not be small, it could be extremely large, okay? Affecting other ignitable components around it, okay? Never overload sockets. That's not the design. We know it happens, but it should not. This is the result of those events. Okay. Sorry. Okay. So, but I'm just trying to make sure I get an angle on this right. Okay, good. Okay. And here we are again, okay, showing you what could happen when you put a nail through a cable and cause massive damage, okay. Okay. Sorry about this. This one seems to I've been seem to be on this one quite a long time. Okay, let's go with that for a moment. Okay. Recognize fault. damage and components. Okay. Appreciate the reasons for and the effects of arcing. Okay. It tells you why it happens and why it should not happen. Okay. But it is your responsibility to look further into this to make sure that your circuits and installation is highly efficient and does not cause a fire hazard to yourself or to anyone else. That's a matter for you. What are the causes of electrical faults? Okay, here are a number of items in regards to electrical faults, but this is by no means exhaustive. As long as we use electricity, there will always be a fault of one type or another. It is your job to make sure that it does not happen, and if it does, that it is limited to the circuits that it has been affected by. Okay, it does not cause damage to others circuits. Now, prior knowledge. Okay, now this bit here, prior knowledge. Before doing any fault finding, you must know the basics of how electrical systems and equipment function if you are to make judgment about what is wrong. Okay, consider an example. Now remember, this is purely an example. A heater has been tested using an ohm meter. You gain a reading of 50 ohms between the line and neutral conductors. Is this piece of equipment functioning properly? A heater is going to be mainly a resistor. Okay, that's apparent. So let's look at a little bit of Ohm's law. We will assume that the supply is 230 volts. Now we are making an assumption that the voltage is 230 volts, even though we know that today's voltage is 230 volts, but there was a time when this voltage was 240, 250 volts. Okay, 50 hertz AC. So what is the current? What we're looking at here is trying to find a current within the circuit, and is it a dangerous current for us? I equals V over R. Sorry, I call this V. I still use this as V. Okay, I equals U over R, but for me it's voltage. U represents voltage, and let me go. U represents this voltage here. Okay, therefore 230 over 50, and we get the 50 from our ohms resistance here. Okay, is this a lot of current flow? Now P equals I squared, R equals I squared equals 1058 watts. Now that is not a lot of power. That is equivalent to what the heater would be expected to give it at 50 ohms resistance. You can see that even with a rough measure we can get a sensible level of power. A 1 kilowatt heater is not unreasonable. So we can see here that a 1 kilowatt power of heat from this is not unreasonable in regards to the resistance of that element. Okay. Now again, make sure you understand Ohm's law, make sure you understand the voltage reference, that this I is current, U is voltage, R is resistance. Now here we're looking at the resistivity of the material itself. So long cable runs, this can lead to excessive volt drop, causing something not to work correctly. Okay, R equals rho L over A. Okay, So what we're looking at here is the resistivity of the material and whether the material has broken down. So cross-sectional area of cable too small, again this can lead to excessive volt drop. Now the longer run the cable is, the higher the voltage drop, and you need to keep that in mind. And I repeat that. The longer the run of cable, the higher the voltage drop. You need to keep your voltage drops within plus or minus as stated within the IE regulations, and I believe it's within 6 volts, maybe less. Okay, so therefore you may need, if you were using 1.5 millimeter cables for a run, you may need to step that up to 2.5 millimeters to ensure that you got the voltage delivered to at the point that you needed it at the correct voltage measurement. Okay. Okay. And as we said here, right, crush cables caused by the laying of floorboards, for example, etc. Okay, there are two equations which you need to remember. I equals U over R or V over R, and P equals I squared R. One, this gives you the current in the circuit. This gives you the power that's been created within the circuit. Okay. 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 Transient voltages. Now these are caused by switching. When equipment that contains inductors and capacitors are regularly switched, then a short-term voltage like spike, transient voltage, is injected onto the system. So every time you switch a light on, you're creating a transient voltage. Sorry. Okay. Okay, let me go. Let me get this into full. Okay. 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 Nothing further. You can read this for yourself. Okay, about transient voltages, and be familiar with it to your own advantage. Okay. Installation failure. Again, I don't need to read this to you. You can read this for yourselves. Okay. So make sure we can get it fully on screen. Okay. And again, there's a danger when you join in new cables. Be aware that if the cable gets hooked on the edge of trunking, or on the edge of a conduit, or on the edge of any material equipment that can cause it to strip, you will have a massive problem when you come to turn on that supply. The problem then is finding where the fault is, and that takes up time. Excess current. Okay, let's just go into, you can see this for yourself in full. Okay, so we can pan it back. Okay. Okay. Short circuits. Okay. Read this for yourself. Don't need me to read it for you at all whatsoever. Well, sorry about it, it's okay. I was just thinking of a little job a guy did for me the other day, or offered me, I should say. Okay, open circuit. And again, this is for you to read for yourselves. Okay, don't need me to be dealing with this on your part or your behalf. Okay, thank you for your time. I hope you found this useful. Have a good day. Bye bye.